Okay, so this is practice test 4. There are 29 questions. I'm going to do non-repeated question only. Number 1, plot the graph of this parabola. First of all, find the vertex. Vertex is 3 comma 4. So, and then I need at least 1 point. So I'm going to choose a point, let's say x equal to 2. So this is the function f of x equal x minus 3 whole square plus 4. Vertex is coming from this 3 comma 4. I'm going to find out the value of the function when x equal to 2, because at least I need 1 point to plot the graph of parabola. When you put x equal to 2 here and do the simplification, that will be 5. So at 2 the value of the function is 5. So I'm going to plot these 2 points. The first one is x 3 4. Second one is it's facing up, so click somewhere, and then the point is at 2 5. You see, when x is 2 the y is 5. So now that's a parabola, but we also have to plot axis of symmetry, which is a line passing through this vertex, vertical line, but we need to use the dashes line for this one. So that's the graph of the parabola with the axis of symmetry. That's perfect. Let's go to the next step. Next step is vertex. We already know it's a 3 comma, what is that, 3 comma 4, and the axis of symmetry is x equal, always it's x equal the x coordinate here of the vertex, which is 3, and then the domain in the interval notation. As you can see here, the graph, the domain is any real number from left side to the right side. So you can just use parentheses from negative infinity to positive infinity. And finally the range is the y value. It is start as the vertex because it's concave up. So from 4, you see here the y value is 4, it's going up, and there is no boundary for the up value. So it's 4 from 4 to infinity. So close bracket for the 4 because 4 is included, and then open bracket for the infinity. So that's the question number 1. Question number 2, we have given quadratic function. We would like to write down this quadratic function as a standard notation like this, and then we can answer all this question like problem number 1. Okay, so how do you go from here to there? You have to complete the square thing. So I'm going to show you how to do it. Question number 2. So you have n of x equal x squared plus 4x. Write down this 3 somewhere far, a little bit far. We have to complete this square by adding square of half of this number, which is 2 square. But you cannot just add some number randomly, so you also have to make it balanced by subtracting the very same number. By doing that, for first 3 numbers, first 3 terms, you can write down x plus 2 whole square. That's called completing the square. Okay, either you write x squared plus 4x plus 2 square, or you write x plus 2 whole square. That's the same thing. You do the calculation here, which is 3 minus 4, so it's eventually be negative 1. So now if you compare this one with the standard equation of the parabola, there is nothing here. That means a is 1, h is, because here sign is plus, you have to make it minus, so h is minus 2 and k is minus 1. And now from that we can answer this question. Vertex is negative 2, negative 1, because h and k is negative 2 for the h and negative 1 for the k. And now we can answer all this question. Okay, so the vertex form of the function is, it's x plus 2 whole square minus 1. It's x Okay, it's x plus 2 whole square x plus 2 whole square minus 1. The vertex is -2, -1. X-intercept means what happens if this function is 0. That's the x-intercept. So meaning if you equate this function nx equals 0 and solve for x, that will help you to find x-intercept. So you can use factoring or what is that, quadratic formula. So 2 plus 1 is 3, so that means x plus 2, x plus 1. Is that the case? No, it's a 3 plus 1 is 3 plus 1 is 3, 3 times 1 is 3, 3 plus 1 is 4, and 3 times 1 is 3. So these are the two factors. So if you solve it, they will give you x equal -3 and -1. So these are the two x-intercepts. So x-intercepts are, use the order pair, so you have to write down this -3, 0. That's how we write down the x-intercept, because the y value for the x-intercept would be 0. -3 and -1 are the two x-intercept. The y-intercept means, look at here, just put x equal to 0 in the given function, it will be 3. So the y-intercept is, in the order pair, when x is 0, the y is 3. And then graph, it's easy to plot. We can plot the vertex, which is -2, -1. We can plot the x-intercept, which is -3, 0, -1, 0. We can plot the y-intercept at 0, the value of y is 3. So with all this information, now we can just click here, put the vertex, which is -2, -1, and then select one of these points. That will be our parabola. What is the axis of symmetry? It's the x coordinate, which is -2, x equal -2. That's our axis of symmetry. Always the minimum value comes from the vertex. As you can see here, it's giving you the minimum value. The function n has minimum value because it's facing up, and the minimum value is the y coordinate of the vertex, which is -1. Always keep in mind, the parabola gives you either maximum value or minimum value. The interval, the domain for the parabola is always all real number, and range comes from, if it's a concave up, starts from the vertex, go up to infinity. So that means it's starts from -1, goes up to infinity. Okay, so that's question number 2. Question number 3, one more time. This is graphing parabola. It's exactly like question number 2, so I'm going to skip it. Plot 5 points on the parabola. This time you have to plot 5 points. You can find the 5 points like we did in problem number 2. You can find the x-intercepts, you can find the y-intercept, you can find the vertex, you can find some other points as well. Okay, I'm going to skip it. Number 4, the graph of quadratic function with the vertex 3, 0 is given here. The range is it's always start from the minimum value, goes up to infinity if it's concave up. In this case, it's concave up, so use close bracket on the left, starts at 0. You see the y value is 0 and it's going up to infinity. The domain is, it's all real number, because domain means it's x coordinate, x values. It's going from -infinity to +infinity, so it's -infinity to +infinity. graph the parabola one more time. You can plot the graph, it's not big deal, but follow the instruction here. You need 5 points. Remember, this parabola has a negative leading coefficient, so that means it's going to be facing down. Okay, find the 5 points, plot it, and facing down. Remember, when you try to use the 5 points, you have to take 2 points to the left of the vertex and 2 points to the right of the vertex. Okay, so I can do this. Let's say number 5. There are 2 ways you can find the vertex. Either you can use the formula for the vertex, which is if you have quadratic function like this, if a is negative, then the graph would be look like this, and vertex can be found where the x coordinate of the vertex can be found by using this formula negative b over 2a. In this case, b is negative 8, 2 times a is negative 2. So if you divide 8 by 4, it's going to give you 2. So that's the x coordinate of the vertex. For finding the y coordinate, which is k, it's actually the value of the function, this function at h. The value of the function at, in this case, it's a 2. So go here and replace x by 2. So negative 2 times 2 is squared, negative 8 times 2, negative 11, and if you just simplify this, it's 8 minus 16 minus 11, and eventually it's okay, I did a little bit mistake here. When I do this calculation, negative times negative is positive, and because of this negative, eventually it will be negative, so it will be negative 2. Okay, so if you plug negative 2 now, if you just replace x by negative 2, this calculation will be a little bit different. So the first case it's negative 8, but the second one it would be negative times negative is positive 16. So now, as you can see here, 16 minus 8 minus 11, it's eventually negative 3. So the vertex is negative 2 comma negative 3. So that's the vertex. And now, after finding the vertex, we need 2 points to the left. So we have to pick something. Let's say x is negative 2. So find the value when x is negative 1. Find the value of the function when x is negative to the left. So that means find the value when x is negative 3, negative 4. To the right, you can choose negative 1, 0, because these are the right points. But you need to find the value of y coordinate for this x coordinate. So I'm going to do that here. If x coordinate is negative 3, the y coordinate would be plug the value of x negative 3 here and do the calculation. That will be negative 2 times negative 3 whole square, negative 8 times negative 3, negative 11, and if you do this calculation on your calculator, it will be 9, negative 18, positive 24 minus 11, so that is eventually negative 29, and then so negative 5. Okay, when x is negative 3, the y is negative 5. Okay, when x is negative 4, the y would be, do this calculation, use your calculator, it would be 32, so that would be negative 11. When x is negative 1, put that value here, it would be negative 2, positive 8, negative 11, so it's negative 5. When x is 0, the y is negative 11. So these are the value I can put. Okay, so these are the points. At negative 3, the y is negative 5. At negative 4, the y is negative 11. At negative 1, the value of y is negative 1. At 0, it's negative 11. So I'm going to plot this value here with the vertex, which is negative 2, negative 3. So click here -2, -3, plot it. -3, at -3 the value is -5, -5, at -1 the value is -5, at -4 the value is -11, and at 0 the value is -11. So plot it. After that, just choose the graph, click it here, facing down, everything done. Okay, so that's number 5. So number 6, answer the following question. This is quadratic function. As you can see here, the value of a, which is leading coefficient, is negative. Negative means facing down. Facing down means you are going to find the maximum value. Where does the minimum or maximum value occurs? In this case, remember, the maximum or minimum value occurs at the vertex. So you need to find the vertex. So vertex can be found by using the same formula, negative b over 2a. When x is negative b over 2a, in this case, b is -4, a is -2, and if you divide 4 by 4 and there is a negative sign, that will give you -1. So when x is -1, that's where you are going to get the maximum value. And what is the maximum value? That's the y coordinate. So when x is -1, what happens to the value of the function? That is maximum value. So I'm going to plug x equal -1 here and do this calculation, which is -2, +4, and eventually that's +2. So that's the maximum value. The maximum value is the y coordinate, +2. Check it. That's question number 6. Question number 7, a ball is thrown vertically upward. After t seconds, its height h in feet is given by the function. This is a quadratic function that represents height after time t. 40t minus 16t squared. After how long will it reach its maximum height? So it's asking us find the you can see here this is quadratic function, -16t squared plus 40t, and because the coefficient of t square is negative, the graph would look like this. So you are looking for this point which is the vertex. So you want to find out at what time, after what time the ball reaches the maximum height, which can be found by using this formula for x coordinate or x coordinate of this point, which is -b over 2a. If you write down this as a times t square plus b times t plus c. So in this case, the b is 40 and then a is -16. So if you just divide this 40 divided by 16, 32, which is 20 divided by 16, and then use your calculator, that will give me I'm going to use my calculator here. 20 divided by 16, it's 1.25. So after 1.25 seconds, do not round your answer. So after 1.25 seconds, the ball will reach at maximum height. That's perfect. Let's go to next problem here. Question number 8. You need to solve this inequality, and to solve this inequality, first of all, you have to find out the zeros for the function you have on the left side. So in this case, you can see the function, let's say f of x is x minus 6 times x plus 5. You want to find out where this function is negative or 0. So first find out where this function is 0. For that, the function itself is x minus 6 times x plus 5. And if you solve this, it will be at 6 and -5. So at these 2 points, the function is 0. So -5 and +6. So here it's 0. Now we need to find out where this function is negative, and then there are 3 intervals from -∞ to -5. from -5 to +6, and from +6 to infinity, you need to write down the interval. Let's say intervals, and then you need to find the testing point, and then value of that function. So from each of these intervals, so first one is from -infinity to -5. I'm going to pick one testing point. Any point would work. Let me just choose -6. Here the value means the value of this function, which is x minus 6 times x plus 5. If I put -6 for x there, it's going to be -6 times -6, -6 minus -6 times -6 plus 5. If you do the math here, it would be negative times negative is positive. So it's a -12 times -1, which is +12. So on this interval, the function is positive. Do exactly the same thing I did, but next interval from -5 to 6, I'm going to pick 0 as a testing point, and I put x equal to 0 here. That's going to be -6 times +5, which is -30. So on this interval, the value of the function is negative. Eventually, the last interval, I'm going to pick 7, which is 7 minus 6 is 1. 7 plus 5 is 12, so it's a 12. It's again positive. So you can see here, only on the middle interval the function is negative, and at 5 and 6 the function is 0. So first of all, go here and use the solid +6 and -5. Sorry, where is that? -5. So pick -5, +6. We have to include these 2 points because of this equality sign. Okay, pick line, and going from here to here, this is what you are looking for. You are not looking for this side. We are looking for this one only. Check. That's great. Question number 9 is very similar to question number 8, but first of all, you have to bring everything on the left side, and you have to find the factors. So if you write down this x squared minus 10x lesser equal -24, first of all, bring this to the left side by adding 24, and that will be negative x squared minus 10x positive 24 is less than 0. Find out the factor of this. 6 times 4 is 24, and -6 times -4 is positive 24. -6 plus -4 is 10. So these are the two factors. By doing exactly the same thing we did before, this gives you at 6 and 4 the function is 0, and then we can divide this into 3 different intervals and find the testing point like we did here. So I'm going to skip this part, find the testing point, and then check where this is negative. Once again, this is very similar problem to the like last 2 question, but instead of 2 factors, you have 3 factors. So if you make all these factors individually equal to 0, these are the 3 points you are going to get: x equal to 1, x equal -4, and x equal +5. So these are the 3 points where the function or this expression on the left side would be 0. So instead of 3 intervals, this time you have 1, 2, 3, 4 intervals: -4 to -infinity to -4, -4 to 1, 1 to 5, and 5 to infinity. Now you have to pick a testing point from each of this interval and check what happens to this whole expression at those testing point. And you need to find out either that function, this expression on the left side would be positive or negative, and then you have to make your conclusion based on that fact, like we did in previous problem number 8. Okay, so I'm going to skip this leftover part for you. Question number 11, for each function graphed, we have given graph of function. We need to find out either they are 1, 2 or not. So one thing you have to keep in mind to check either given function, given graph is 1, 2 or not, you have to apply the horizontal line test. If you see any horizontal line intersect that graph more than once, that means that's not 1 to 1. For example, first one, you can see here there are so many points. You can see what I'm trying to say is, first graph, this is the graph, there are so many horizontal lines you can see which will be intersect this graph at more than one point. So this is no. Here you can see once again the very same story, even the x-axis is intersecting more than once. This one, no horizontal line is going to intersect at more than once, so this is yes. Remember, this is open circle means no point, solid means it's a yes point. Oh sorry, if you draw a horizontal line here, even the x-axis, it's intersecting at more than one point, so it's also no. I'm sorry about that. Okay, even the x-axis is intersecting here and then here, so it's no. For graph 4, no horizontal line is intersecting more than one point, so the answer is yes. S means it's a one-to-one function. Same number 5, same number 6. So these are the answer for this question. Let's go to next problem. Find inverse, check either these two functions are inverse of each other or not, and this is how you can check. If two functions are inverse, then composition of these two functions supposed to give you, from both sides, supposed to give you x as your output. So we are going to find out f composite of z first, which is finding the value of f at g of x. So meaning, go to the function f here, for wherever you see x, just replace that x by some box, and in that box plug the value of g of x. That's the meaning of finding f at g of x. So g of x, we can see here it's x plus 1 over 4. So now open that box and do the simplification. So this 4 and this 4 is gone, and then x plus 1 minus 1, which is x. That's what we were expecting. So the first test is okay, that passes the first test. We have to do the same thing for the second one. So z composite f of x means finding the value of z at f of x. Go to the function z here, copy that, but at x just replace that x by box, and in that box plug the value of f of x, which is 4x minus 1. So if you open that box and do the calculation, it's going to give you 4x over 4, and eventually that's going to be x. So since both of these requirements, they are true, so these two functions are inverse of each other. Okay, now find the inverse of this function g of x. You can do that by following some steps. So the first step is write down this function as a y, and replace this y by x, and replace this x by y, and now solve for y. To solve for y, meaning everything else goes to one side, the y goes to other side. So here is the 3, so first of all multiply both sides by 3. By doing that, you are going to get 6 minus y. You also have to bring this 6 on the other side, so subtract 6. So that will be 3x minus 6 equal negative y. We don't need negative y, we need positive y, so just multiply both sides by negative 1. By doing that, this negative becomes positive. So y equal negative 3x, negative 6. So this y finally represents the inverse of the given function. So inverse of g of x is negative 3x and negative 6 if you want to use the parentheses. Otherwise you can just open the parentheses and eventually it's going to be negative 3x positive 6. So it's a negative 3x and positive 6. Okay, find the inverse. This is exactly the same thing we did before in problem number 13, so I'm going to skip it. I'm going to go to question number 15. Exactly the same way. Write down the function as y and then replace x and y, and then isolate y. and that is going to be your inverse function. So go to number 16 one more time. This is about the inverse function, but it's a little bit different than previous problem. So let's talk about this. We have given one-to-one function f. The domain of this function f is -1 to positive infinity. So that means the function f is going from -1 to positive infinity. That's the domain. Going from here to the range 4 to infinity. So that's the range. Now inverse means going back. So when you go back, this range of the function f becomes the domain of f inverse. So that's the reason the domain of the f inverse is this 4 comma positive infinity. It's just a reverse of the original function. And then range is the domain of the original function, which is -1 comma positive infinity. That's all. Let's go to next problem. Question number 17. When you try to plot the graph of inverse function, you just have to switch x and y coordinate. And for a graph like this graph is combination of 3 different lines, 1, 2, and 3. So you just have to switch, you just have to plot these critical points, 1, 2, 3, 4 points. So the inverse of this point, which is 8 comma 7, is 7 comma 8. So I'm going to plot 7 comma 8. Do you see that? So inverse of this 8 comma 7, if you switch x and y coordinate, that becomes 7 comma 8. So now go to this point, which is 7 comma 3, that becomes 3 comma 7. Now go to this point, which is positive 2 comma -3, that becomes -3 comma positive 2. You just have to switch x and y coordinate of these 4 points. Finally, this point is -2 comma -4, that becomes -4 comma -2. Now the thing is, after plotting all these 4 points, you just have to join them by using straight line. Okay, that's all. So that's the graph of inverse of this function. Find the, plot the graph for exponential function. So as you can see here, plot 5 points on the graph of the function. So for finding the 5 points, you can always find the table for the points first. So this is, choose x and find the value of f of x by using this formula, which is -5/8 to the power -x. So I'm going to choose x equal 0 because that's easy to choose. When I replace this x by 0, this expression becomes 1. So that is going to give me -1. So at 0, the value of this function is -1. I'm going to choose, because it's negative, I'm going to choose some negative value. Let's say -1 for x. So if I replace this x by -1, that negative and this negative already here becomes +1. So eventually this value of the function becomes -5/8, which is at -1, the value of the function is -5/8. If I choose x equal 1, then this becomes -1. -1 means you just have to flip this. 5/8 to the power -1 becomes 8/5. So eventually the value would be -8/5. So at +1, the value would be -8/5. We need 2 more points. So if I choose, let's say 2 here, 2, so that becomes -5/8 to the power -2. So -5/8 to the power -2. You can plot, you can just simplify this. This negative makes this reverse, just reverse it, and that becomes +2. And then 8 square is 64, 5 square is 25, so that gives you -64/25. So let's do very last one for the -2. Since there is a negative and this negative becomes +2, So eventually that would be 25 over 64, because 5 square is 24 and then 80 square is 64. So I'm going to plot these values. You can see here at 0 the value is -1. Plot it. At 1 the value is -8 over 5. If you don't remember that, at 1 the value is -8 over 5. At -1, it's just a flip of that value, it would be -5 over 8. At +2 the value would be negative, let's double check, +2, it's -64 over 25. 64 over 25. And at +2 the value, okay, I put for the +2, so I'm going to put for the -2, the value would be at -2, it would be -25 over 64. -25 over 64. You just have to plus these 5 points, plot 5 points on the graph of the function, and also draw the asymptote. So remember, this is your exponential function. For the exponential function like this, b to the power x, the graph is look like this, and this line, this line is your asymptote. But if you try to plot the graph for negative of that, this graph becomes like this, but asymptote would be still same. So the value of b in this case is 5 over 8. 5 over 8 is less than 1, so it would be the type of the graph would be actually look like this, but the asymptote is still the x-axis. And then when you try to plot the minus of it, that's going to be like this. Okay, so choose this one, that's the choose the asymptotes. It's not vertical asymptotes, it's horizontal asymptote. What is that? This is the one. Put it here and then choose the graph and check it. Great. Question number 19, it's the same as the previous problem, but here is one more thing you have to do. You have to start with the graph of 2 to the power x, which is actually this one, and there is a vertical asymptote, this one, but you have to do the transformation this time. From 2 to the power x, you have to go to the 2 to the power x plus 1, which is horizontal shift to the left 1 unit. This graph, take this graph, shift it 1 unit to the left, and -4, shift that graph 4 unit down. So its translation is 1 unit left, this point goes here, and 4 unit down. Yes, so this point 0 1 becomes -1 -3. Yeah, okay, it's a horizontal shift to the left and vertical shift down. Okay, find the range and domain. As you can see here, the domain is everything. No, domain is from -infinity to +infinity if you want to use interval notation. But if you don't want to use the interval notation, here they are saying write your answer as inequality, as x or y. So first they are asking you what's the range. Range means the y value. The y value is starting from -3 but not including -3. So y is greater than -3. Sorry, that's the range. Y is greater than -3, and then x is all real number because it's going from -infinity to +infinity. You see that? For whenever you start from -infinity and then there is an arrow, that means it's keep going. So the domain is all real number, and that's the case for exponential function. For the exponential function, domain is all real number. This is the graph of exponential function, like the way we did for problem number 19. It's exactly the same thing, but one has just a horizontal shift to the left. Okay, find the domain. Domain is all real number. Find the range. The range, it's above the asymptote. So you can find, you know the asymptote is y equal to 0. So the range would be from 0 to infinity. Plotting the graph, it's the same graph but shifted 3 units to the left. Okay, so the domain is all real numbers, which is from negative infinity to positive infinity. Range is from, what is that, from 0 to positive infinity, not including 0 because y equals 0 is your asymptote. And finally the graph is this is your horizontal asymptote, and plot some points. Plot 2 points on the graph of the function. So 2 points would be at 0. If you put x equal to 0 here, the value would be 3 to the power 3, which is what is that? It would be 3 times 3 times 3, which is 27. So we don't have the boundary, the space for the 27, so we need something else. So let's start from negative 3. Instead of at 0, at negative 3, the value of the function would be 1. You remember that 0, 1 point, just shift to negative 3, 1. And now pick negative 2. If you pick the negative 2, that will be 3 to the power negative 2 plus 3, which is 3. And pick negative 1, that will be 3 to the power negative 1 plus 3, which is be 9. Do you have 9 here? Now at negative 1, here is the 9. Yeah, that's point available. So just click it here, click on these points, then that's enough. Okay, I'm not going to repeat the very same thing. This is exponential function, and use some translation, and then you are going to find the answer for this. 23, use a calculator. So what is the calculator here? This one, and then find out this value. It's easy peasy. So e to the power 0.1 equal 1.105, but it's saying do not round any intermediate. Round your answer to the nearest 1000. 1000 means after decimal there should be 3 digits, 1, 0 and 5. So it's a 1.10 and 5. The next one is 350 times e to the power negative 0.75. Enter. It's 165.328. Remember, after 8 there is a 2, which is less than less than 5. That's why it stays 8. Okay, go to number 24. Solve this exponential equation. So remember, one thing you have to know, if there is an equation like this with the same base on both sides, then the exponent, this would be equal. So in this case, if you can convert this 27 as a base of something and then 81 as a base of very same base, then we can solve that problem by using this relation. So we know 27 is actually 3 to the power 3. 81 is actually 3 to the power 4. So we can convert this problem as 3 to the power 3 to the power negative x minus 5 and 3 to the power 4. So the meaning, because they have the same base 3 and 3, the rest of the thing, like 3 times negative x minus 5 equal 4, this would be equal. So now just solve this one. So this is negative 3x negative 15 equal 4. Add 15 that is negative 3x equal 19. So just divide both sides by negative 3. That's going to give you x equal negative 19 over 3. So the answer for this one is negative 19 over 3. Okay, great. Let's go to the next problem here. Problem number 25. Exactly the same thing. 3 to the power 3c minus 6. This 1 over 9 can be written as 9 to the power 1. What I'm trying to say is this 1 over 9 is actually 9 to the power negative 1. And 9 is actually 3 to the power 2. So this 1 over 9 is actually 3 to the power negative 2. So we can change this problem as a 3 to the power 3c minus 6. And on the right side, it's a 3 to the power negative 2c plus 3. Now just equate these two values here and solve for c. I'm going to skip this. Exactly the same thing. Bring this e to the power 3 on the top. Change the position and that will be e to the power negative 3. And solve this equation. E to the power 2x plus 3 equal e to the power negative 3. So this is actually 2x plus 3 equal negative 3. And now if you try to solve this equation, then just subtract 3 and then divide it by 2. So x would be negative 3. So when you type your answer is a set, so you just have to put x equal negative 3 here. Okay, this is an application problem for exponential exponential function. You have to know formula for this. Here, read the question. Dan borrow $8,000 at rate of 7.5% compounded annually. So you have to know that compound formula. So this is the formula I'm talking about. A equal P times 1 plus R over N to the power N times T, where P stands for the principal, R stands for the rate, N is number of times compounded annually, and T is number of years. So in this case, principal is 8,000, so P is 8,000. Rate is 7.5%, which is, you have to write it down in this form, 0.075. Compounded annually means N equal 1. Assuming he makes no payment, how much will he owe after 6 years? So time is 6. So you plug this value back here using a calculator. So we have a calculator available. So it's 8,000 times 1 plus R is 0.075 divided by N, which is 1. So eventually to the power N times T. N is 1, so T is 6, so N times T would be 6. If you hit enter, that's the amount he owes. What's the question? How much will he owe? So that means it's if you round it to the nearest cents, it would be 12,346 dollar 41 cents. An initial amount of 2,100 is invested in an account at an interest rate compounded continuously. So here, instead of using compound n times a year, we need to use compounded continuously, which is A equal P times e to the power R times T. The initial amount P is given, rate is given, and then time is 7 years. You just have to use this formula. So it's a 2,100 e to the power 0.05. Time is, what is the time? 7. Just type this thing using this calculator here. 2,100 times e to the power 0.05 times 7. Enter it. It's a 2,980 point how many cents? 1 cent. 0 cents. Nearest cents, so it's a 0.04. So 2,980. Yeah, if you round it to the nearest cents, that should be rounded to your answer. Okay, be careful. 0.0. Your answer is incorrect. What did I do wrong here? So let me go back and check. What is that? This one. I just typed 2100 times e to the power 0.05. Sorry, what is that? 2100 e to the power 0.05 times compounded continuously 7 years. 7, yes, equal, it's a 2980.04. I did not put 4 here, so that's the answer. It's a 4 cents. So I forgot to round it to the nearest cents, or not forgot, but I did it wrong. So finally, question number 29. How much should be invested now at an interest rate of 6% per year compounded continuously? Very same formula, but instead of finding A, you're finding P. So the formula is A equal P times e to the power r times t. So to find the P, you just divide both sides by r times t, e to the power r times t. So that will help us finding the initial value P. So how much you want to make? That's A, which is 1500. E, what is the rate? It's 0.06 times how many years? 5 years. So type this expression here using the calculator. 1500 divided by e to the power 0.06 times 5. That will give you the number rounded to the nearest cents, $1,111.23. Don't forget that, because after this 2 there is a 7, so you have to round it this 2 to the next number, which is 23. So it's 1111.23. That's all.